Today, uh, Brandon and myself will talk about the information regarding moment frame design. Here's a quick presentation overview of the topics that we'll cover. I'll talk about the background and some of the testing and design codes that have evolved over the years. It followed by going over just really brief overview of the current pre-qualified special moment frame connections, and then we'll take a quick break, and Brandon Winter will then follow up with the second part of this presentation. So starting a little bit about history of moment frame design, the steel frame that were used and put together in the early turn of the century here, 1900s, were actually still done using a rivet connection, and the built-up section with the mechanical fastening system using the rivets actually performed pretty well in terms of the lateral loads and lateral movements. In the 1906 San Francisco earthquake, a lot of the buildings actually survived the main movement or the earthquake itself. Unfortunately, it was the fire that did most of the extensive damage that brought down much of the city. And then from the 1960s up until 1994 here, and we'll talk about the significance of 1994 in a minute, the trend and the assembly of the moment frame connection started to evolve. We moved away from the traditional bolted connection to the field welded connection with the improvements in welding technology. Because of the extensive additional work and time that is required to make that connection, that moment connection, designers started to then concentrate the moment frame bays to limit the number of the bays that are required. So we started to see the concentration to reduce the number of bays and having the trade-off of using large members then for those concentrated areas. Up until then, there were research done on these special moment frame connections, but they were relatively limited. So starting, just taking a time here, it goes way further back, but we look at 1971 with the Loma Prieta, the San Fernando earthquake and the extensive damage that was observed there. There were a lot of damage to masonry and concrete building. And at the time, there were a few welded steel moment frame buildings that were being used. And so although there were some damages that were observed to some of these steel buildings, a lot of the focus was on making the concrete and the masonry buildings more robust. The steel moment frame wasn't as well understood just yet, and so where they saw damages, they made the repair and moved on. We then had the Loma Prieta earthquake back in '89, and we saw again URM and some of these non-ductile concrete buildings play in terms of focus very apparent on the extensive damage to those URM and concrete buildings. Again, steel moment frame buildings, the welded steel moment frame buildings appeared to perform well. We didn't we didn't have a significant catastrophic failure of these moment frames that were observed. Although when we come back later, they did actually reveal that some of the damages were actually existing that got overlooked. There were some testing done then from the Loma Prieta earthquake, and the repaired wells the testing actually showed that some of the repaired welds, there were actually quite a large number of them, and the correlation to those were the deep members that were observed to have a lot of defects or deficiencies for the bottom flange.